Hi everyone, it's Justin again. In this lesson, you're going to build on your knowledge from the previous lesson in order to calculate the volume of pyramids and cones. My friend Marie made a simulation for you about this topic. It's a short activity that comes right before your notes template for this lesson. Pause the video now so that you can go through it. By the end of this lesson, you will be able to calculate the volume of pyramids and cones. First, we'll compare the volume of pyramids and cones to the volume of prisms and cylinders in order to develop a formula. Then we'll use that formula to complete an example problem. We can start by comparing the volume of pyramids to the volume of prisms. Let's think back to the previous lesson. In that lesson, we worked with prisms and used this formula to calculate their volumes. Remember that capital V represents volume, capital B represents the area of one of the bases, and capital H represents the distance between the bases. Okay, so we learned that in the previous lesson. But what does that have to do with this lesson? Well, here's a pyramid. And this pyramid happens to have the exact same base area as this prism. That means that the value of big B is going to be the same for both of these figures. These figures also happen to have the same height. We already know that on a prism, the height is the distance between the bases. But on a pyramid, the height is the distance between the base and the apex. The apex is the vertex that is farthest away from the base. This also means that a lateral edge like this is not the height of a pyramid. Just like in many two-dimensional polygons, the height is perpendicular to the base. So since both big B and big H are the same for both of these figures, do you think we can use the same formula to calculate the volume of both of them? In other words, do you think that the same amount of water would fit inside both of these? Hopefully you're thinking that the prism would hold more water than the pyramid. And if so, then you're absolutely right. But how much more can the prism hold? Well, let me show you. Let's orient this pyramid so that we can fill it up with something like water, for example. If this amount gets poured into the prism, how full do you think the prism will become? If you're thinking that it would fill up 1/3 of the way, then you're absolutely right. This means that we would have to fill the pyramid and pour its contents into the cylinder not one, but 2 more times to fill it all the way up. So what does this mean for the formula of a pyramid? Well, here's the formula for a prism again. How can we change this formula to make it work for a pyramid? That's right, a pyramid has 1/3 of the volume of a prism with the same variables of big B and big H. This is because 3 times 1/3 equals 1 whole. And what about cones? How do you think their volume is related to the volume of cylinders? Maybe you're thinking about the activity you did before starting this video. My friend Marie showed us that a cone with the same big B value and the same big H value as a cylinder could be oriented so that it can be filled and poured into the cylinder 3 times to completely fill it, meaning the volume of the cone is 1/3 the volume of the cylinder. And here's an important thing to remember. Just like with pyramids and prisms, it's important to make sure that the height is perpendicular to the base. Don't accidentally use the slant height. So, we have our new formula, and we know where it comes from. Now you can use it to complete this problem. It says to find the volume of the given cone. Since this formula is so similar to what it was in the previous lesson, except that now it includes 1/3 because we're working with pyramids and cones, I think you have the knowledge to do this entire problem by yourself. Give it a try now and see if you can get all the way to a final answer. You probably worked on big B first. Since the base is a circle, finding its area requires the area of a circle formula. Let's take the radius and substitute it in. Now, remember, I don't want to calculate this value yet, because I don't want to take a rounded answer and substitute it in for big B. That could create rounding errors later on. So let's just take this entire expression and substitute it in. Then we need to substitute the height of the cone in for big H. Which of these remaining numbers, 9.7 or 10.0, is the height of this cone? 10.0 is the slant height, which we do not need in our calculation at all. 9.7 is the height, since it's perpendicular to the base, so let's substitute that in for big H. What should we do next? Yep, let's type this all into our calculator, starting with 1/3 times pi times 2.3 squared times 9.7. If you haven't done this already, try it now. You should get 53.7 when rounding to the tenths place. And units squared times units is, of course, units cubed. Now you can calculate the volume of pyramids and cones. And you'll always remember where the formula came from because of my friend Marie's simulation. See you next time!
Hey.